video, we're going to use two new limit formulas that came from the proofs of the two derivative formulas for sine and cosine. So the two formulas that we're going to use are the limit as theta approaches 0 of sine theta over theta equals 1, and the limit as theta approaches 0 of cosine theta minus 1 over theta equals 0. These two limits are worth memorizing because they'll come up over and over and they will simplify your life. Notice that both of them have fractions. So the first one is sine theta over theta. The second one is cosine theta minus 1 over theta. Both of those have indeterminate form 0 over 0. Because remember, sine of 0 is 0. And also, cosine of 0 is 1. So cosine of 0 minus 1 is 0. So both of these have indeterminate form 0 over 0. And we've seen in the past lots of limits that have that indeterminate form. Sometimes the limit doesn't exist. It might approach infinity or negative infinity, which means it doesn't exist. Sometimes it's a number and it does exist. Sometimes it's a positive number. Sometimes it turns out to be a negative number. And sometimes it turns out to be 0. So we call it an indeterminate form because it's not the same thing as undefined. It just means we have to do something else to figure out what it is. And so now we have these two new, very useful limit formulas that we can use for more complicated limits involving trig functions. So let's look at some examples. So the first example, we're going to compute the limit as x approaches 0 of sine of 2x over 7x. Notice that as x approaches 0, 2x is also approaching 0. So the sine of 2x is approaching 0. So the numerator is approaching 0 here. Also notice the denominator, 7x, that approaches 0. So we have another indeterminate form of 0 over 0. So we got to do something. And we would like to use the first limit above. The limit as theta approaches 0 of sine theta over theta equals 1. We would like to use that, but we don't have it in the same form. We have sine of something over something else. And we would like to have sine of 2x over 2x. The thing in the denominator needs to be the same as whatever we're taking the sine of in the numerator. So we're going to do a little bit of algebra to kind of rewrite our limit, and we'll also use some limit laws and hopefully be able to use the formula above. So the first thing I'm going to do is get that 7 sort of away from that x. So I'm just going to factor out a 1/7. So I have the limit as x approaches 0 of 1/7 times sine of 2x over x. And now, notice all I need is a 2 in the denominator, so I can have a 2x down there. In order to get that, I just need to multiply the denominator by 2. But whenever we do that, we have to multiply the numerator by the same thing. We don't want to change the value of the fraction. So I'm going to multiply by 2 over 2. And because I'm multiplying 2 times the sine of something in the numerator, the 2 can be written in the front of the sine of 2x. I could just put the 2 before or after. So I'll put it before. And that means I'm doing the limit as x approaches 0 of 2/7 times sine of 2x over 2x. Great. So we've got the sine of 2x over 2x, but what about that 2/7? Well, the limit laws tell us we can pull that outside of the limit, right? The limit of a constant times a function is the same as the constant times the limit of the function as long as the limit exists. So I'll rewrite it as 2/7 times the limit of, and now I'm writing theta approaches 0 because I'm using theta to represent 2x. So this is sine of theta over theta. Theta is just 2x in this limit. Now we have everything where we need it, and we know the limit of sine of theta over theta as theta approaches 0. That limit is going to be 1. So what we have is 2/7 times the limit, which is just 2 over 7. So it was a little algebra and limit laws, and we were able to use the formula above. It's very, very important that when you look at something like this, when you look at my work, you know that I did not do the following. I did not pull the 2 outside of the sine of 2x. That you cannot do, right? Sine of 2 pi is not the same as 2 times sine of pi. You cannot pull constants outside of trig functions. All right, so what I did was I did a little algebra, multiplied top and bottom by the same number, pulled the fraction outside of the limit, and then just replaced the 2x with some other symbol. I used theta in this one. All right, so be very, very careful when you use these formulas. And when you're reading other people's work, like when you're reading the examples in the textbook, or my examples, or the answer key in WebAssign, you understand nobody's pulling a number outside of a sine or a cosine function. All right, let's do another one. In this one, we're going to do the limit as x approaches 0 of cosine x minus 1 over sine x. Now this one has a cosine and a sine in it, so we're going to actually use both of the limit formulas. So what we like to have is the cosine x minus 1, we want that to be over x, right? Because the formula is the limit as theta approaches 0 of cosine theta minus 1 over theta. So we need an x in the denominator. But also, for the sine x, we would like an x in that denominator too. So we'd like both fractions to appear in this limit. So all we need to do is multiply top and bottom by 1 over x, or divide top and bottom by x, right? We're not changing the value of the fraction because we're multiplying top and bottom by the same number. When I do that, I get the limit as x approaches 0 of cosine x minus 1 over x over sine x over x. Okay, now we've got both fractions that we need, and we can use limit laws. The limit law for quotient says that the limit of a quotient is a quotient of the limits as long as both limits exist. So I rewrite this as the limit as x approaches 0 of cosine x minus 1 over x over the limit as x approaches 0 of sine x over x. And now, since both those limits exist, by the two formulas we have, we've got 0 over 1, which is just 0. All right, you'll have a few of these limits in upcoming assignments, and we'll be using them all semester. And I'll see you in some other video.